Okay, first off, I do want to point out that these recorded videos, the thing you're watching right now, these are required. They count for points, and it's required that you watch the entire thing to get those points. If you don't want to watch it, that's fine. But then don't lie and say you did watch it if you didn't. In that, I watched the whole video, true or false. If you didn't watch the whole thing, put false. Because if you claimed you watched it and you didn't, that's getting points for something you didn't earn. That's cheating. Like, that's academic dishonesty. Don't lie about watching these. And the reason I make a big deal out of this is I get like 100 emails a week, and probably 70% of those are somebody asking a question that I've answered in these Zoom meetings, because they're clearly not watching the meetings. I mean, it's fine to, like, you've watched the meeting and you just need some clarification. Then, you start your email with, hey, I did watch the whole video and I don't understand this thing, whatever. Can you help me? That's perfectly fine. I'm not saying don't email me. I'm saying that if you're emailing me some procedural question and you haven't even watched the Zoom meeting, then most of the time my response is, did you watch the meeting? Because I spent 10 minutes talking about that. Don't lie and say you watched them. Don't play on Reddit and let the video play back in the background. That's not watching it. Watching it means have it on your screen and watch it. These count for points. Don't lie and say you're watching it if you're not. So, like, I go into student view here. And the issue is, a lot of the people that really need to hear this are maybe not watching the video. There's the link. Click it, watch the entire thing. You can watch it at double speed. Right here, you can change the speed. Like that one there was a 25-minute video. Here are the numbers from that video. It was a 25-minute video. I wish there were a way where we track of each individual person so I could see like who's doing what. But like that person there, obviously didn't watch it. This person didn't watch the whole thing. Or they could have, like this 12-minute, maybe that person was watching it at double speed and it just rounded. Maybe it was more like 12 and a half. You know what I mean? So that person obviously could have watched the whole thing. That person didn't. See, and like there, didn't watch the whole thing. Didn't watch the whole thing. Obviously didn't. These are required. You got to watch the whole thing. Or when you take the little quiz, tell the truth. Say, no, I didn't watch the whole thing. Hit false on that. Otherwise, that's cheating. You're like, I'm not being facetious here. You could fail the class for that. That's getting points for something you didn't do. Okay, make sure you're checking the announcements too. If we go here to home, up here on the top, I'm scrolled up. I posted this a few days ago. This one I didn't make required. It's just an extra video. There were a lot of issues on histograms. So if you got points off on your individual assessment or the group assignment and you want to know what went wrong, I go through like all the common mistakes here in this video. Go watch that. I also posted, I think I talked about this in the last video here, some handwritten solutions to some more normal model problems. I just finished grading the box plot written assessment. So let's go over that. Make sure I am recording. Yeah, okay. Okay, so again, use your calculator. Some of you are still trying to do these by hand. Well, I don't know how else to say this. You're not going to make it through this class if you don't have a graphing calculator. It's required for the course. Like I've said this over and over again. And some of you, I can tell, still don't have a graphing calculator. Send me an email and I'll help you figure out how to get one. It's required. You don't have to do this by hand. This whole problem should have taken you like 2 minutes, maybe 5 minutes to type all these into the calculator. So the calculator spits these out, your 5-number summary. That's the minimum, Q1, the median, also known as Q2, Q3, and the max. The IQR is this distance here of that middle 50%, 20. Then we find our fences, like there's the math, you can just see it. Anything outside the fences is an outlier. Anything below 16 is an outlier. So we look up here, yeah, I've got 2 outliers down here, 2 and 7, they're below 16. Anything above the upper, anything bigger than 96 would be an outlier on top. There's nothing here bigger than 96. So our only outliers are 2 and 7. Okay, then we draw our box plot. So we start with our median. A lot of issues here. Start with your median and go down to Q1 and up to Q3. That's your box. That's not going to change. Whether you have outliers or not, that's your box. Then for the whiskers can't go outside the fences. My upper whisker wants to go as high as it can without crossing over 96. It's like The Price is Right. I want to get as close as I can to 96 without crossing over. So what's my biggest data value? 80. Doesn't cross over the fence. Go as high as you can without crossing the fence. Same thing on the bottom. Draw your whisker as low as you can without going past 16. So I'm going down. I don't want to cross over 16. Oh, once I get past here, those two would be below 16. I can't go that low. That's the lowest I can go right there without crossing over 16. So the lower whisker goes down to 23, not down to the fence. Like you don't even have to draw the fences. Then once we got our box plot drawn, we just throw on our outliers using star. I told you to use star here, so 2 and 7. So this is what you should have had. So the main issues were people drawing this whisker all the way down to 2 or drawing it down to 16. And that's not what happens. Okay. I made up another normal model problem. Let's go through this. Remember, test 1 is coming up, and quite a bit of it is going to be on the normal model. Pretty much a lot of what we do from now on depends on the normal model. I'm trying to make that big. There we go. Okay, so we've got some normal distribution we're told about. Our population mean, mu, that's the symbol mu. You got to know what all the letters stand for. Is 1,000. And our population standard deviation, sigma, is 80. Part A says, let's use the empirical rule. Remember the 68, 95, 99, 7 rule. It's just an estimate. It's an approximation. So let's use that to estimate what fraction of the scores were between these two. So I draw my normal model. Right here in the middle is the population mean. In this case, that's 1,000. My standard deviation is 80. So if I go up and down 80, so between 920 and 980, up and down 80, that's 68%. Between there and there. Remember, this empirical rule is also known as the 68, 95, 99.7 rule. If I go 2 standard deviations, I go down another 80. So 920 minus 80 would be 840. And I go up another 80. That's an ugly 1080 right there. That says 1080. If I go up another 80, that would put me at what? 1160? 95% are between here and here. And I could go one more, but I won't need it to answer this question. Okay, so now I want, what do I want from 840 to 1080? I want all of this here. So that's going to be more than 68. I had 68 between here and here. That was 68%. It's not going to be 95 because 95 goes all the way up to here, but I'm stopping here at 1080. So I need to figure out what this little chunk right here is. I could find out each of these individual pieces and add them together. The way I'm looking at this is I know it's 95 from here to here. So I've gone too far. I'm going to find this little sliver right here and subtract that out from the 95. Okay, so let's think about this. We're going to have to do a little thinking here, a little math. Between 920 and 1080, I had 68%. That means above here and below here is 32%. Everything left over. I'm just doing 100 minus 68 would be 32% left over split between these two wings here. Well, this is a normal models are symmetric, so that's got to be split evenly. So this has to be 16%. 16 above there, 16 below here. Okay, so all of this, let me change color here. Everything above there would be 16. That's all of that. I don't want this little bit there, though. What would that little chunk there be? Well, I had 95 from here to here. That leaves me 5% over. So 5% split between, I don't know why it's not writing. What? My pen suddenly stopped writing. Sorry, let me try unplugging it and plugging it back in. Okay, I got it working. So 5% split between here and here. So that means those two little chunks. Maybe I'll do blue. This little chunk here and this one here have to add up to 5, and they got to be, each of that is half, so 2.5 here. So all of this yellow was 16. This much is 2.5. So this must be, just this piece right here must be, maybe we'll do green. 16 minus 2.5, which would be what, 13.5. That's this little green chunk right there. So 95 from here to here minus the 13.5 I don't want would be, get another color here. I'm running out of colors. this purple section. So the purple is 95% minus 13.5%, if all my arithmetic is correct, which I think is like 81.5%. Again, I'm doing the arithmetic in my head. That was a lot of work, and that's just an approximation. Like, those make good questions so that you get a feel for the normal model. Like, I like to put these in homework. You might even have a test question with empirical rule. But the whole point of that is just so you start to get a feeling for how big these different areas are. If we wanted to calculate the actual answer, we just use z-scores, and we're going to get a more accurate answer, and it's going to be a lot easier. So let me pull up my calculator here. Again, you got to have one of these graphing calculators. Okay, so I want to be between 840 and 1080. So I draw my picture. 3 steps: draw the picture, find your z-score, normal CDF. The mean was 1,000. I want to be between 840 and 1080. That's 1080. So I shade that. I find each z-score. Find each z-score. For 840, the z-score is the one I'm looking for, the one I'm asking about at the moment, 840, minus the number in the middle, the population mean, 1,000, divided by the standard deviation, which was 80. So type that in my calculator. $840 minus 1,000. I like to do the top first, hit enter, then divide by 80. It's -2. 840 was 2 standard deviations below the mean. Okay, my next one, 1080. Find each z-score separately. The one I'm interested in minus the one in the middle, divided by the standard deviation. You can check this on your own. You get 1. Because that guy right there is 1 standard deviation above the mean. Now I do normal CDF, smallest z-score to largest z-score. So I get out my calculator. Let me write this. -2 to 1. Get out my fancy calculator. Go to second distribution, number 2. Smallest to largest, -2, 1. Leave these 2 numbers alone. Do not change these unless you really know what you're doing. Do not change these in your calculator. You will mess it up and you'll get every single question wrong. And look, that's not the exact same answer I got up here using empirical rule, because the empirical rule was just a rough approximation. It's pretty good, but z-scores get you a more accurate answer. So you've got a homework question that's like this. If you do it using z-scores, you're actually getting the right answer, but it's not going to give you credit because the question asks you to do it using empirical rule. So it won't take this answer. It will only take, obviously that is a decimal, 0.815. Okay, so here we get 0.819. And then of course we would write that in a complete sentence. 81.9% of test scores are between 840 and 1080. Okay, what percent are above 1100? See, here I'm going to have to use z-scores. That empirical rule, I could kind of estimate it. I could kind of get a guess, but it's not going to give me an accurate number at all because I never hit 1100 exactly using the empirical rule. So here I draw my picture. I got to use z-scores. Right in the middle. For this distribution, mu was 1,000. Here's the guy I'm interested in, 1,100. And the question says above. So I'm going to go above. I find my z-score. The one I'm interested in, 1,100, minus the one in the middle, divided by my standard deviation. So make sure you watch me type that. Plus my 80. All right, so we type that in. Type in the whole top, hit enter, then divided by 80. I get a z-score of 1.25. Z-score is only your final answer if the question just says find the z-score. Then you're done. Here we're not. Question didn't say that. If it did, if it said find and interpret that z-score, we would say that a score of 1,100 is 1.25 standard deviations above the mean. It's not what it's asking for, though. All right, now I'm going to shade. Oh, I already shaded. Look at that. I shaded above because it said above. I'm going to do normal CDF. Smallest z-score I shaded to the largest. How far does this go? Well, it goes to infinity. Z equals infinity is up here. Z equals 125, 1.25 was here. So I really want to go to infinity, but there's no way to type that in the calculator. You can't type infinity. So we type next closest thing, we type 99. So second distribution, number 2, never number 1. 1.25 to 99. Leave mu and sigma alone. 10 point, we'll go to the third place, 10.6%. So 10.6% of scores are above 1,100. I physically don't have space, or I would type that out. Okay, what about this one? Hope you read the question. Scores are below 903. So same 3 steps every time. Draw your picture. Right in the middle here is 1,000. Remember, the mean's not always 1,000. That's just the example we're doing here. I want to be below 903. So I'm going to, 903 is below 1,000. That's why I drew it down here. I shaded below because it says below. I find my z-score. The one I'm interested in minus the one in the middle, divided by my current standard deviation. Type that in our fancy calculator. Remember, if you get a z-score of like 100, you've done goofed. I guarantee it. Z-score, big z-scores are like 4. Most of your z-scores are going to be between -3 and 3. Here we get -121. You want to round z-scores to 2 decimal places. And then normal CDF. What's the smallest thing I shaded? How far down did I go? I went down to -infinity up to this guy's z-score. We're always putting z-scores in here, -1.21. So second distribution, negative 99. Remember, if you type that button right there, it's going to yell at you. You're going to get an error. This is the negative button right here. Negative 1.21. Before I hit enter, let's kind of estimate what we think the answer is going to be. Look how little I shaded. I'm 1 standard deviation below the mean. At exactly 1 standard deviation, like we just kind of did this, 1 standard deviation below the mean from 920 backwards would be 16%. I'm a little more than that. See, instead of at 920, I'm at 903. I got a little smaller tail. I'm going to get like 10%. That's what I'm expecting. 11%. 0.113. So 11.3% of scores are below 903. Okay, and then one more here. Find and interpret the 80th percentile. So this is a percentile question. We're working backwards. I can draw that better. That's a little better. Not perfect, but it's right in the middle is our mean of 1,000. I want the area here. I want this chunk to be 0.80. 80%. This is who I'm looking for. That test score that has 80% below him. So for percentile questions, we use a different button on the calculator. Inverse norm. That's right. Here in distributions again. So the area, again, there are shortcuts I know you can use on some questions. Like not on this one. I couldn't do any kind of shortcut. But if you always do things the same way, you don't have to memorize a bunch of shortcuts. The area below the point I'm interested in is 0.80. So I'm always, for me, I always leave this on left and I always use the area below. Then it's always the same question. 0.80. I don't have to type the 80. Leave these two alone. Again, I know there are shortcuts, but unless you really know what you're doing, you're going to mess things up. 0.842. So that's a z-score that spit out, 0.842. That's this guy's z-score. I got to work backwards and find him. Let's call this guy x. Then x equals z sigma plus mu. Have this written down in your notes. If you get a test coming up, make sure you have this written. It's an open note test. Make sure you have this written down somewhere because you're going to use it. X equals z sigma plus mu. So x will be z. Inverse norm spits out a z-score times my standard deviation plus my mean, which was 1,000. And I can just do that all in my calculator. I can do that last answer times the standard deviation plus the mean, 1,000. 1067. So, like, I should look at my picture and make sure that makes some sense to me. Does it look like here, if I'm up at 1067, 80% or below? Yeah, it's pretty far up there. That makes sense to me. Now, how do we interpret that? What would we type here? We would type 80% of test scores are below 1067. Oh, we could equivalently say 20% or above. That means the same thing, but this is a better interpretation, I would argue, because it's like, that's what it's asking. Asking about 80, let's use 80 in our answer. That's a common mistake. A lot of times people will get here and they'll just say the 80th percentile is 1067. That's a true statement, but that doesn't interpret. What's that mean to be at the 80th percentile? Means you're above 80% of the population. Okay, let's talk about all the different symbols you need to know for the test. So the test is coming up. You should have been keeping this the whole semester so far, a nice detailed list of all the different letters, like in the back of your notebook on the last page. If you haven't been, go through and write all those down now. So we've got N, which is sample size. That's when you're taking a small sample, how many are in the sample? We've got X bar, or sometimes like your book will call it Y bar. Either one of those means sample mean. We've got S. Your calculator calls it SX. I usually just call it S. That's the sample standard deviation. That's the one you use if you only have a small sample out of the population. Then we had sigma. Let me draw sigma a little better here. Yeah, that's good enough. This is a population standard deviation. This is if you have an entire population. This is if you take a small sample from a population. They have different formulas. That's why they have different symbols. We have our population mean, mu. We always use Greek letters for population parameters and R letters for Roman letters for sample statistics. So mu, a Greek letter, means population. That's the population mean. We've got, the people get this one wrong all the time, Z. That's our Z score. That one's easy. Throughout the semester, we're going to have like 8 different formulas for Z score. So the only formula we have right now is Z equals X minus mu over sigma. I don't want you to, like, you can memorize that if you want, but I want you to think the one you want minus the one in the middle of the picture you just drew divided by your standard deviation. While we're writing formulas for percentile, it's the exact same formula, just solving for X. X equals Z sigma plus mu. Other variables we have S squared. That's the sample variance. Like, I think we calculated one in one of the videos. We're never, ever going to find variance by hand. Back when I took this class, we had to do this by hand, and it takes forever. In one of the written assignments, some of you did that. Like, you had 2 pages of math. Please never find variance by hand. It takes forever. You got these calculators, use them. Same idea for population variance. Sigma squared is the population variance. Of course, I mean, we've got our Q1, our Q3, our quartiles. I think that's all the symbols we have at this point. You gotta know what they all stand for. Okay, so we've got, when's the practice test due? Here, let's take a look at this assignment. Here's the actual assignment. Okay, so this is a group assignment coming up. Most of you are, or everybody that's getting credit has already turned in their draft. So we've got a normal distribution. They tell us the population mean, population standard deviation. We're going to find a couple of probabilities. You got it. 3 steps. You have to show all your work. Draw your picture, find your z-score, normal CDF. Your answer is a complete sentence. This is a percentile problem. I want you to be careful with this. This says top 2%, not bottom 2%. So think about which percentile you're actually finding here. All right, we got this individual assignment coming up. Notice, by the way, here in the assignment, I've got links to a bunch of the videos. Yeah, I had a student meeting with one of the students the other day. And she was stating that going back and re-watching the old videos sometimes is kind of frustrating because of the questions that pop up. Like I've pointed this out before, but I don't think many people realize this. You can always just go to my YouTube channel if you want to watch these videos without the questions popping up. I'll post it in the announcement, a link to my YouTube channel, and you can just type in the name. Here's my channel. Yeah, okay. You can always just search for normal model or whatever. Or you can go to the playlist about statistics, like here are all the videos for the whole semester, plus some extra stuff. Like I probably in here have some practice tests and other stuff that are not the lecture video. So look, there's practice final solutions and so forth. Okay. So I just want you to be aware of that. You can always, I don't know if that download, you can always just go straight to the YouTube channel after you've watched the lecture video and gotten the points and answered all the quiz questions that pop up. Like you still got to do that. That's my way of making sure you did watch it. Okay, so we got this assignment. It's a lot like the one I just did. Make sure here on these, you interpret the percentiles. Don't just say the 90th percentile is 60 minutes or whatever. What's that mean? And then think about this. It's funny. A lot more people get this question wrong than should. Actually think about the setup of the problem. And let's look at our calendar here. Let's see when things are due. Okay, so we got our calendar loading. Let's see, what day are we on here? Today's the 30th, right? So practice test 1 is due tomorrow, or in a couple of days. You must complete the entire thing. Practice tests are all or nothing. Like I already showed you where the solutions are. I'll show you again. You got to work every single problem. If you skip, it takes me like half an hour. but I go through and I look at everyone's. And let's say I'm going through your whole thing and you skip part B of number 5, but you did everything else. Get a 0 on the assignment. You got to do every single question. Because what's the point in having a practice test if you're not going to at least try every problem? It doesn't have to be perfect. I'm not grading it. I'm checking, did you make an honest attempt at it? So these are the kinds of things that'll be on your actual test. Determining if you've got categorical versus quantitative data. Categorical data just puts you in a category. You can't find the average of it. Like somebody's area code. Like I'm just going to tell you, area code is categorical. Because even though it's numbers, you can't find average area code. You can find the average number of classes somebody's taking. If you can take an average of it, it's quantitative. One variable stats, drawing histograms, interpreting histograms, skew, symmetry, modality, how many modes we have. Remember, in skewed data, the mean is on the skewed side. Skewed distributions are not normal. Normal distributions are symmetric. Normal model problems, like the ones we were just doing today. Empirical world problems. We did one of those today. One variable stats. Again, your calculator does this for you. You type all these numbers into the calculator. It'll spit out almost everything here. It won't tell you range, and it won't tell you interquartile range. Maybe I should put those on our list here for formulas. I'm going to upload this document. Range is max minus min. Range is not a list of numbers. It's one single number. Interquartile range is Q3 minus Q1. Here are the buttons you use on the calculator. So here's a list of how to get to everything. Make sure you got all this written down in your notes, but you should have enough experience with the calculator that you don't have to look it up, that you just know how to get to different things, because you don't want to run out of time on the test. Okay, on Wednesday, I will go through the actual solutions to all of those. Your test opens on Thursday, I think. Yeah, it opens on the 2nd. So it's open 2nd, 3rd, 4th, and 5th. It's open for 4 days. And it said here how long you have. You have 2 hours. Plenty of time. Now, don't wait until the last minute to take the test, though. Like if your time runs out at midnight or 11:59 and you haven't finished the test, it's just going to give you a 0 on all the other questions. Don't wait until the last minute. On Wednesday, I will go over the solutions to the practice test. Like I'll spend more time on it. And of course, I'll post that video on Wednesday. You might want to wait and watch that before you take the test, because that video won't be due until Sunday. Like, don't take the test and then watch me go over the practice test. Do it the other way around. Make sure you have watched this entire video. And the practice test solutions, did I post those in an announcement? Yeah, right here. So these are my solutions. Again, I'll go through and talk more about those on Wednesday. If you have any questions, feel free to send me an email.